That's what you will be doing within this particular section, SQL tutorial here. And then you have SQL database, where you will learn about how to create a database, how to drop a database. Drop means removing everything. Delete means structure will be there, but data will be deleted completely. So how to drop that, how to take backups so that right you can retrieve from the backups also if required, and how to create tables. Similarly, how to drop tables and how to alter table. Alter table is a way by which you can change the structure of a table. You can add new columns, you can change the data type of the a column, and all such kind of things are possible by using alter table. Constraints is very important in order to maintain a database that is going to be consistent. For example, you have created a structure. While creating a structure itself, you can inform the server so that it will accept the data only when only when the constraints are satisfied. For example, you may have an ID, name, age, and several things. The ID there must be some value to the ID. There must be some name to that. That means it should not be null. So such kind of constraints can be enforced by using SQL constraints. Not null kind of thing. Unique is another constraint, and so on. So that's what you are having here. Not null, unique constraint. Similarly, you can make one of the column or even a group of columns to act as a key, so that all those group of columns together is going to maintain a unique value. And then the key will help you to retrieve the data very fast. Tree will also help you to identify the rows or the records that are to be updated, that are to be changed, that are to be deleted, right? You can select based on that particular uniqueness kind of entity. So you have all these related stuff. So try to learn these things also, SQL database. At least everything you should learn with respect to the MySQL. He is going to give syntax and semantics of all the databases, including the Oracle SQL Server of Microsoft. Maybe DB2 is not there, and all those related stuff. Right? So this also is required. References section may not be required. So it actually talks about everything in detail. You don't have to go into the details, but you can refer that. No issue. And SQL examples certificate also, it's better you go through that so that you can possibly get a certificate also from w3schools as a part of an exercise. Right? You can showcase that. You can build your profile slowly, one by one. Right, so this is what I am expecting all of you to go through in detail on SQL tutorial that you see to the left of this particular thing completely. And then SQL database, complete thing, you need to learn definitely. References a little bit, depending upon your capacity there. SQL server function, MS Access is not required, but MySQL functions you can. Right? Take a look into that particular. Ultimately, examples, yes, go through that particular thing. Only one side I am now focusing, so that at least this much, each one of you is expected to learn. Something beyond, you can always, like going through tutorials point or directly like reference material straight away, SQL quick reference. That is up to the extension knowledge, whatever is actually required. Okay, so that is one aspect of it. Today, I will also talk about something called database design. A little bit of database design I want to talk about.
Sir, last two classes not uploaded in YouTube, sir.
I have not uploaded, in fact, because of some a little bit busy. I am occupied. I will upload. No issue.
Okay, sir. Thank you, sir.
So database design. Database design is there. Like what do you mean by database design? Means essentially data means various like values of your requirement. You want to store and retrieve uh, data of a particular application. So first of all, one should identify what is the application for which you want to design the database design. You have to first identify what is the application for which you want to do all this exercise. Definitely there must be some client for you, somebody who is asking to develop a software for that particular organization. So when you interact with them, that interaction is called as normally software requirements. You have to capture the requirements of the SRS, right? Normally you also sometimes call as software requirement specification. So by interacting with the client, you will get to know what they want to do. What is that they are currently doing? Like manually means they must be still maintaining some records, physical records, books, like ledger books, invoice books, so or maybe payroll books, depending upon the nature of uh, the business that they do, they will be maintaining all that in the form of books. Now, when you want to automate that, or when you want to develop software for that, you have to capture all those details into the software and then still run the same business, in fact. Maybe a little bit of re-engineering to improve further, but all that with the consent of the your client, like whoever is actually giving you the work. So now let us take some simple example and then see how we are going to go about database design. What do you mean by that? So that kind of bigger picture. For example, like always, like we are fancy about our college because that's what we are well versed with, or a kind of a transport system, right? We can think of. You can think of anything for that matter. To begin with, let us say simple college, right? So you want to develop some college information system, right? College info system. So that means first of all you have to interact with the college people, the administration or the management, whoever are there. So what is that you are currently doing? Can you please show all your records? So when you go through the records, then you will identify various data items. Normally you call them as data items. Capture all the data items that they are actually currently working on. Just simply enumerate, simply write down. Simply write down everything that they are actually maintaining as a part of a record. That is the first level actually. After that, you can actually group these various items or entities, right? Sometimes another word for items is entities. That's why entity relationship diagrams, you normally call it. ER diagrams, right? So you try to identify data items or fields, columns, you call them anything. So in the context of the college, for example, what do you normally see, right? So every college, like in general, it may have its own name, right? College name. College name. So all the items you are trying to enumerate now, let us say. The college may be given a code because the college may come under another entity called university or something, right? Under a particular university, a college is running. So university is likely to give some name, some ID. Most of the times in day-to-day world, apart from the names or whatever, we are going to maintain IDs also because IDs are going to be short and easy to work on within the computer system. Name is variable, right? Most of the times. Variable in the sense the number of characters present in a college name may vary from one college to another college. So comparison is going to be a little bit tedious thing. Whereas IDs means if in case you take IDs to be numbers, comparing number is going to be a one-time affair. Straight away you can compare. Whereas if you want to compare names, you cannot compare names straight away. What is that you have to do? You have to compare character by character. You have to compare the first character of this with the first character of the other one. If both of them are equal, then you have to compare the second character of this with the second character of the other one. So like that, so many comparisons are going to happen in a variable length names. That's why a majority of times you go with IDs, which are going to be fixed length, and in case you take that to be what you call a number, comparison becomes much more simpler in fact. Anyhow, so that is one aspect of it. College ID will have, college name is there. And then what else? College may be located in a particular place and all that. You may have to maintain the address of that particular thing. So probably address also is required. And then sometimes if you want to maintain like what is the location, the address itself may contain all those details, or if you want to store separately, there may be something called what is the district within which this college is located, right? So you want to maintain that particular thing. And then what is the state within which it's going to be located, that also you can maintain. So you just simply write down everything that is relevant to that particular college information system. And all these things, remember, will happen over a number of meetings or over a number of iterations. It doesn't happen just with one interaction, everything won't happen. Only you are likely to get 50% of information. So next time when you go and then you present that, yes, this is what we are thinking, is this correct? Then they will add something more. So no, we have forgotten, there is some more details. Please capture these things also. So it is a continuous, it takes time for external people to understand intricacies of a complete system. So anyhow, this is about the college you are talking about. Similarly, there may be faculty, right, within the college. So the faculty name or the teacher name or maybe what you call lecturer name, whatever you call it, faculty name, right? Again, faculty can be given an ID so that you can easily do all that. Faculty ID is there, is required. And what else do we want to capture as a part of the faculty? So majority of time, some more personal details you would like to capture. What is the gender? What is the age or probably date of birth? Date of birth is more relevant so that it's going to take care of dynamically, like what is the age. Age is a static entity. It never changes. Whereas if we capture date of birth, then we can always calculate what his age is by comparing the current date with date of birth. How many days or how many years are passed by and all that. So it's always a good idea to capture date of birth rather than age straight away. Similarly, date of joining, right? So when is the person has joined this particular organization? And what is the designation of this particular candidate, right? So all the relevant details, you have to capture them. And if you examine here, you are actually trying to group some of the related columns together as a single entity, right? All the related things you are bringing together under one entity. But you don't have to do that way in the very beginning. But to some approximation, you can always do that. But after capturing all the individual items, then you have to group them into related things, right? How to handle all that and so on. And then like faculty, like what is the subject that he is going to handle, right? That also you require. Considering that probably whether he is going to take a single subject or multiple subjects, right? How are you going to handle? So that's a big question that one has to actually look into. If it is a single subject, yes, we can, let us say. If it is multiple, then what is that? Are you going to say subject 1, subject 2? Right? That is one possibility. The other possibility is as a part of the design, those things will actually come, right? So probably here we will just simply say subjects. So many subjects that like this faculty is likely to handle. So slowly it's going to increase actually. Whenever you want to build any information system, it's going to, like, the number of items are going to increase enormously. And how are you going to link all of them together? Because this entire thing has to work as a single system. Right? Similarly, student. Student will have a name associated with this. Again, student will have an ID. And then probably what is the like branch or what is the degree? Is it a B.Tech or M.Tech or MCE? What is that? Right? So that kind of information also is to be captured. So program, probably. You can call it as a program or degree, whatever you call it. Program name. And within the program, specialization, branch, wherever there is a possibility. And again, whether this fellow is in the first year, second year, third year. So that is another, this thing, semester come year kind of thing. If it is a semester system, you can as well just simply say semester. So are you going to put this now as a part of the student, or will it be separate there? That also we'll have to look into. So many other details are to be captured, in fact, like it will expand like anything. So in fact, it's difficult also to teach all this as an online kind of thing. But I'm just trying to talk about how people are going to approach, right? So keep that in mind. And after that, there are so many other things like normalization. Some of you might be familiar with first normalization, second normal form, third normal form. So those are the ways in which how to group all these items into separate entities so that it's going to be more like what you call, it can be handled in a easier manner. Like there are certain anomalies that you might have actually heard of. There are certain anomalies are there in database design. Insertion anomaly, update anomaly, deletion anomaly, kind of things. So you should try to design the database or design all these tables and all that so that these anomalies should not arise, should not be present. So some of these student name, student ID, program name, branch, semester, like that. So this is one way of looking at it actually.
We can say naming convention.
It is not naming convention actually. Like, so first of all, one thing is we are talking about software requirement specification, how to capture whenever some company which is already running, but running in a physical record fashion. You are now want to automate that. How are you going to approach? What is the first day? Day one, what are you going to do it? Right? That's what we are actually talking about. So because we have some idea, you also have some idea, I'm just naming all this. But most likely, for example, you take up some customer whose activity you have no idea at all, let us say. But still they are asking you to like develop an information system. You are familiar with about how to develop computer systems, computer information system, programming and all that. But you have no knowledge of their business. So what it is and all that. How are you going to deal with? Right? So for that, normally what you do is you just have a meeting with higher level people and request the higher level people to give an order to all the people who are maintaining records to like display or show all those records to your computer personnel. And what you have to do, you have to just simply name all of them that they are actually maintaining within the physical systems, physical books, whatever. So you just simply write first all of them. And then you will be asking the questions. Like we also have some common sense will be there, definitely. So which are all have like close association, which are the not so close association kind of thing. For example, when you are creating a student table, you don't maintain a faculty information within that. Why? Because whenever you want to create a student record, there is no point in knowing who the teacher is. There must be flexibility. So when you are creating a student, only student details must be captured. That is what a common sense is, and even as a part of the design also, that's a correct design. But sometimes we may get confused sometimes, because student also, because he will be like some teacher must come to the student. So let us maintain student details also here. Right? So that kind of short-sightedness is likely to jump in. So similarly, as a part of the teacher also, you will be maintaining only teacher details. But then how are you going to say that this teacher is going to handle this student? Right? Somewhere you require a mechanism to say that so-and-so teacher is handling a subject to so-and-so group of students. How are you going to deal with that kind of situation? So you may have to create other additional tables. One table exclusively for student table, where only student details will be available. Another table exclusively for faculty, where only faculty details are available. But then now you want to create a class, probably. A class where there are a number of students are registered for that particular class, and a teacher is associated with that particular class. Right? So you require a mechanism now within your database design, so that you need to create another table now. These are all concepts, right? So some general ideas we are actually talking about. For example, what can we say now? For example, I'm talking about class, right? So class table or whatever. So within this class, what is likely to be there naturally? The class must have a class name, right? So it can have a class ID also wherever required. Class ID. And what are the various subjects that are there and all that? Let us assume. What are the subjects associated with that particular? Whoever registers for this particular class, there will be all those related subjects will be maintained here. Let us assume for the time being. You start thinking it's not complete actually. I'm not giving any, it's not like 2 + 2 = 4, not like that. So you have to think so what is the right approach? In spite of all this, even those who have rich experience in projects doing and all that, if you give one system to be developed to 2 different people, they may come with 2 different designs. That's okay as long as they actually substantiate, or they are going to give why they are choosing such a design. Let us come to that, like what we are actually doing here. So this table will be there. But then what is the table where students, faculty, and class is going to come? So that's what this is going to be there. There will be another table actually. So which we call them as linked tables, you can say. Class students, right? So you can say that. Class students means, so within this class, all the students, like everything. So how are you going to deal with it? Normally, with respect to each one of the earlier classes, you identify an ID, right? This ID is most of the time is going to become a primary key. This ID is going to be unique for every record. It's going to be unique, and many a times it's going to act as a primary key. Now, while creating the link tables, this kind of what I call a table that contain information about other tables, you will be using the primary keys of the other table as a foreign key here. So here what you will have is class ID will be there as a part of this particular thing. Class ID will be there. Similarly, student ID will be there. This is how you are actually linking student ID, the ID that is coming from student table, class ID that is coming from class table, right? And then similarly, who are the teachers that are going to come here? Probably teacher ID. Can be there as a part of that. So, strictly speaking, like either these two can only, this is only class students actually. Teacher ID, again, it's likely to become null actually. So you can have just simply like this, even. Class students table is going to have class ID versus student ID. So there may be 50 records against a particular class ID, assuming that there are 50 students. Right? There will be as many as 50 records. So what is the advantage of this? You are maintaining actually student information at only one place. Class information also at only one place. Whereas class students here, using this link table, you are combining students with this particular class. So if at any point of time, any student information is to be updated, you need to update only at one place. Because the ID won't change, only other details are likely to be changed. Spelling mistakes of whatever, all those details can always be changed. So this is how you are going to build the tables. Similarly, class teacher, right? Class teacher also you require one more. That means to that class, who are all the teachers that are engaged? Who are all the teachers that are engaged? Within this, you will have. Again, as a part of this, you will have class ID and then teacher ID coming from teacher resource. Like this. This is a design actually now. You are taking an important design decision. You are not putting teacher names as a part of the class, or you are not putting student names as a part of the class, because there it's going to be very difficult to manage. Now, if you want to know who are the students and teachers, both if you want to know, you can always combine these two together. If you combine class students with class teachers, you will get both class ID, student ID, teacher ID. So all the details you are going to get. If you want to know even student names also, teacher names also, then you combine, for example, class students with students table. If you combine class students with students table, you will get student name and other details. So that is how, by joining your link tables with the main tables, you will get all the other details, because you have the ID number. ID number is there with this particular entity. So this is what you mean by database design means. Instead of keeping every information in a single table, you are collecting the details and then creating only those tables whose details are closely related. Right? All those details are closely related. Student details, whatever the student-centric information only will be there in a student table. Nothing else is going to be recorded as a part of the student. Right? Anything that's going to be there is going to be separated out. Similarly, faculty also. And then a class now, you are constructing or building a class with students and teachers, which are already there as a separate tables. So you will only capture those IDs and then form a class with that particular entity. Who are all the students there as a part of that, and so on. So it requires a little bit more, you may have to spend or invest a little bit more time to appreciate this thinking process. So here only, you will be learning many things about the relationship between different tables is going to be one-to-one, is one possibility. one-to-one relationships. This is what you might be studying as a part of ER diagrams and all that. Similarly, one-to-many. One-to-many. And this side, many will come, the other side, one and many can come. Many to one, many to many. So these possibilities are there. What you really mean by is that one class ID can contain many students. That is one kind of relationship. Probably if your design demands that one class is going to be handled by a single teacher, then it's going to be one-to-one. Relationship between a class and a teacher is going to be one-to-one if your school is running such that only one teacher is going to handle the class. Then the design should be one-to-one. If a class is going to be handled by many teachers, then your design should be one-to-many. You will have to look for that particular approach. So with this background, maybe like when you study database management system, DBMS thoroughly, then you will go into some more details. But this is have this kind of thought in the background whenever you are creating tables and all that. So what are the closely, in fact, this entire design, whatever we are talking about, is also meaningful with respect to class design or object-oriented design or analysis and design kind of thing. Even there, an object or the template of an object is called as a class, right? So again, you are saying that a class. So a class here in the object-oriented concept is nothing but an entity in the context of a database system. So slowly, when you learn all these things, you will get to know that your database entities and your like object-oriented classes will have a lot of relationship. That's where again, when you are developing information systems and all that, there is something called ORM, Object Relationship Model, right? So where you are going to link as a part of your programming, your objects. That's nothing but your object-oriented. Under that, your object may equivalent to indirectly classes and all that. How they are mapped to relationships or the tables within your data modeling. So ORM is going to help you in that particular direction. Like keep only these things in the mind. Later you recollect what I am actually saying. Then you will actually appreciate so what's going on there and all that. Any other questions probably at this point of time? So are you all there, like following something at least? Are you getting something? All your papers are valued, in fact, but the performance is very poor. So marks, I will post them next time when I go to the college. But all of you actually have to work a little harder, and definitely you may have to prepare well for the second week. Most likely only that performance is going to be better. So syntax and semantics of the language, especially what is happening, like unfortunate also, as I have been saying that you must use a computer system, write programs, only then you can do better. So without that, just simply listening here, coming to the class is going to be very difficult because you will be writing totally unconnected things. So anyhow, so that is one aspect of it. So I hope that you are slowly following what we are actually talking about. Let's come back to this particular thing. Database design, I think too much also is not required. But somewhere, even at least in the internet, you search for database design or anomalies. insertion anomaly, update anomaly, and then deletion anomaly. Those three also you try to actually learn from the internet. Anomalies are there. And then one to one, one to many, many to one, many to many. What are those relationship models and how to actually handle them? Just go through those related stuff. So, and then slowly coming to the create table. Let's actually come to so that I will just show you some of them. Create table statement, general syntax is actually giving. Already all of you are familiar with. And this is one example that he is actually giving. Create table using another table is another way, and he is coming to this. That's all. But constraints and all that is different. Okay, let us elaborate one by one and slowly understand what he is actually talking about. So create table, already all of you are familiar, no issue. Create table, table name, bracket begin, column names, space, data types. Data types can be integer, varchar followed by value, and all that. These are the popular things anyhow. Bracket begin, semicolon. This is when you want to create a table for the first time, freshly. But if the table is already existing, you want to create another table with the same structure, then there is another way, right? If it's something is already there, you want to create another similar structure, then it's going to be somewhat different. Let us see here. Create table using another table. This is the general syntax. And as you can see here, create table, table name, as. You see here the keyword as. As what? Select customer name, comma, contact name from customers. That means you are not actually creating the complete structure, but you are creating a structure with only these two columns. Only with these two columns. So these two columns will be there within the new table, whose table name is test table. These are simple things. The only thing is you must have, like, syntax is simple. It is a highly common sense oriented computer science subject, actually. But if you take that to be a kind of a phobia, what is all this, then it's very difficult. You must see, like, it's just like English language, right? Which has got certain syntax, subject, predicate, object, right? Like that, there is a structure to everything. So you have to always see that. And here he is highlighting all the keywords. Create, table, as, select, from, those are all the keywords. And the other things are variables. So create table, test table can be replaced by any other name also. A different name, as, select. And these names naturally must be available within this particular table called customers. Otherwise this syntax, this select will fail. Right? Anyhow, two versions. One is a version where you are creating a fresh table. The other one is creating a table from an existing table. And for that, create table, table name as, and then a query. Add as followed by a query. And you can always test it here. So simply, right? It's not a difficult thing at all. And then, like, he's also giving you the certain exercises here, whether you are following or not following. It's a very well designed kind of thing. Drop table is simple way, no issue. So straight away drop table, table name, right? There is hardly anything to that particular thing, right? Drop table means it removes the structure. It also removes the data. It is a highly dangerous command. Whereas retaining the structure but removing the data is going to be by using the truncate table. Truncate table is going to remove the complete data, but the structure will still be there. Truncate table, table name. Drop table, entire thing. Nothing will be there, no traces. Right? So that is about this. Alter table. Whenever you want to change the structure, you have already created a table. You might have even added or inserted some data to that, and then you realize, like you are interacting with your customer and your client is saying that no, I have missed this particular column. This also must be there. Then you may have to actually change the table structure, and for that it's called as alter table. So there are certain constraints within which you can always do that anyhow, because already data is there. And to that means whenever you are altering, meaning that you are adding one more column, meaning that to all the existing data also, what value must be there then? What is the value that must be stored against the existing records on that new column? If there is clarity in that, no issue. If there is no clarity, then you may have to actually work around right from the scratch and all that. Right? So if you can update the existing records by using some kind of logic, then no issue, right? And how are you going to alter the table? Command is alter table, table name. What is the existing table whose structure is to be changed? And after that, what are you doing? Add a column name data type, right? You are adding another column. Similarly, you can even remove that. So one column may be there. Your client is saying, this column, I don't want to maintain that. You should be able to remove that particular thing. So you can see here, alter table statement is used to add, delete, or modify columns in an existing table. You can do any of these things. You can add another column, you can remove existing column, or you can change some of the, either the data type can be changed or some other constraints can be changed. You can see here, alter table, customers table, add email, varchar of 2. That's all. With this now, the customers table is going to be added with one more column name. Right? So you can always try for yourself and all that. So similarly, how are you going to remove an existing column? Alter table, table name. Instead of add, you say drop column. Here you are not saying add column. You are just simply saying add. Whereas while dropping, you are saying drop column. So these small things you should always try to remember. It's not consistent there. It should have been add column would have been better. But somehow they have designed that. So because we are using their system, we need to use the syntax of that particular language. So add followed by column name data type. Whereas drop drop column name, column followed by column name. Drop column, column. That's what you are actually doing. So just now you have added a column. Immediately you can also remove that. So you can say alter table customers, drop column email. Right? So you can always do that. Similarly, you can also modify whatever. Here at this level, alter modify for different servers is actually giving syntax different. So what I am asking you is to learn only this part, MySQL part. These things you don't have to learn. But if you have capacity, you can always, no issue. But as far as this course is concerned, this much knowledge is expected. For MySQL, alter table, table name, modify, see. So earlier you have specified alter column, right? So whereas like add column, so similarly drop column, whatever. Now you are saying modify column, and then column name and data type. So you are able to modify that particular thing. So as an example also is likely to give one more SQL alter table example. These are the various things. So alter table persons, add date of birth, date. This you can easily understand, right? No issue. You're only adding one more example is actually showing. One more example. And if you see the date, like data here, already this data is existing. And a new column is added, date of birth column. And if you see data against this column, nothing is there. All are null values. All are null values. At some point, you may have to add data to this also by using update command. By using update command. Change data type of a particular column. You can always do that. Alter table persons, alter column, column name followed by what? Whatever. What is the data type, new data type that you want to? You can always specify that. Similarly, drop column, alter table persons, drop column, data. So it's just simply showing the impact of running a particular alter table, how the table structures are continuously changed. So much in detail he is giving. It's really very simple. Even a 10th class student can easily understand. In fact, many a times they are also doing little projects in many schools. So only thing is you must have belief in your skills, in your own this thing. A little bit of English knowledge is required, little bit. You don't have to be proficient there, but minimum knowledge is expected. And you must have reading skills, a little bit of patience to go through that, and again try, see what is the result. Is it like matching with your understanding? Not. All that is very much required. Constraints now, even though I've been saying that, you can just take a look into what are the constraints here, how we can impose. This is how the syntax is. At the time of earlier create table, it was a simple table creation without any constraints. But now he is slowly adding that. How are you going to do that? Create table name, bracket, column name, data type. Earlier only to this extent you have stopped. But now you are actually putting column name, data type, and then constraints also will immediately follow. This is a syntax. What is the syntax of that? Column name, data type of that, constraint on that particular column, comma. Another column, another data type, another constraint, and so on. This is a general syntax. And then from server to server, these things are likely to change. What are the constraints? These are the constraints. Not null constraint, unique constraint, primary key. It is a foreign key. Check for certain integrity constraint. What should be the default value? Whenever you insert another row without specifying a column, then for that particular column, what is the default value that is to be stored? Whether indexing is required or not required, all those things, right? Only this much. The actual examples will be there in the next following thing. Not null. You can see here how he is going to create a not null constraint. You can see here, create table name bracket. ID is a column name, int is a data type, and here this is a constraint. Just simply say not null, come. That means whenever you say like this, then after this, when you are inserting data into the table by using insert into persons of, then if you don't specify data for any column whose constraint is not null, then that record will not be inserted. So the system will never allow any data which violates these constraints. That is the advantage. At the time of creating the table itself, you specify all the constraints so that any data that is captured into that table is going to be meaningful, is going to be like a error-free kind of thing. So if you don't put any constraints, every data is going to be taken up. No verification will happen. Whereas if you put like this, at least the minimum thing is some data it is accepted. Without a data, it's not going to accept. Simply say, ID is not null, I'm not accepting your record. Your first name is not there, you again enter. So that kind of thing. Whereas here, age int, no constraint is added. That means it's going to accept records without the age being filled. So it all depends upon your database design again. This is also a part of the database design. These constraints will come naturally from the corresponding organization to which you are developing the software. If they say that like first name must be there, then just simply say not null. Then wherever that you are actually collecting the data, if the end user is not supplying, it will just simply say not possible, please supply. Right? So this is the advantage of creating tables with appropriate constraints so that proper data is going to come. So you can see unique constraint. There is another constraint called as unique constraint. So just only take a look into MySQL. That is always better. So you can see here, create table persons, ID int not null, last name varchar not null, first name varchar 255, age integer, comma, unique of ID. So he is saying like that. So at the end, he is not actually giving the constraint there itself. Instead of that, at the end, unique of ID. That means the value of ID must be unique across all the records. So if one of the person is given an ID of 100, let us say, then you cannot insert any other record of some other person with an ID of 100. Because student IDs, person IDs, Aadhaar ID kind of thing, those are all unique. You cannot have duplicate values there. So such kind of things you can just simply apply unique constraint, unique of ID. This is in MySQL. Whereas if you see here in SQL Server or Oracle or MS Access, the syntax is simple even. ID int not null, there itself you say unique. But don't learn too many things and then mix up. Because for you, it's only MySQL is there. So you should learn MySQL syntax. General idea must be there. You know, like a specific syntax and semantics of MySQL also you must learn. Right? So general idea to see that in case in future you want to switch to these databases, you should be able to simply do that. It's only a matter of syntax change, but the idea is the same. Right? So unique of ID. It's also possible to combine two different columns and then maintain uniqueness. The two values together, it must be unique. For example, last name and first name together, it must be unique, let us say. Then you can say unique of last name, comma, first name. It is also possible. So constraints can also be given names. In fact, sometimes here you can see here what he is talking about. MySQL, SQL Server, all across. To name a unique constraint and to define a unique constraint on multiple columns, use the following syntax. What is he saying? ID, integer not null, last name varchar not null, first name age, constraint keyword, and then constraint name. This name can be anything. You can choose any name. Constraint name, and then what is the constraint actually? Unique of ID comma last name. Unique of ID comma last name. This is the actual constraint name. So we are expecting the ID coupled with last name together to be unique. Together must be unique, and this is constraint is given as UC underscore person. So that is also to create in that particular fashion. So you can see like you want to change the table. Initially you have created without any constraint. Later you want to modify the table with constraints. So how do you do that? Alter table persons, add unique of ID. ID column is already there. You are assuming that ID column is already there, but earlier constraint was not added, but now you are adding in this particular fashion. Right? You can always do that. So everything is common sense, right? So simple. So similarly, you can say alter table persons, add constraint, UC underscore person, unique of this particular. Like this also, you can always do that. And you want to drop a constraint, you should be able to do that. Alter table persons, drop index, followed by constraint name. Drop index, followed by constraint name. And constraint name is already given here. With this constraint, any constraint is already added, that one is going to be removed. Like this. Right? So it's better actually you go through that and practice. Then it's so simple. I want to see that because somehow still I understand that you are not following. That's why I'm just showing as a part of it. But always remember, it's only when you involve yourself in the learning process you will learn. So otherwise it's difficult. Primary key, you can see here how you can do that. MySQL. Create table persons, ID int not null, last name, first name, age at the end. What is the constraint name for the primary key? It is primary space key of ID. Unique constraint is unique of ID. Primary key means actually, strictly speaking, primary key is indirectly means actually unique and not null. Primary key will ensure that like data for ID must be not null, and also it's going to be unique in nature. So that's why here you can see here ID int not null primary key. So anyhow, so both the things you can You should be able to understand. And with constraint name and all that, you can always do that. Constraint name, primary key of ID, comma, last name. Right? You can always have names associated with the constraint so that at the time of dropping or something, just simply mentioning the constraint name, you can remove it very easily. And you can always alter table kind of thing and removing that kind of thing. All these things you should easily understand. But now one next thing is the foreign key. Because just now we have seen, we have created the main tables like student table, faculty table, class table. And then you are creating link tables. Link table will refer to the primary keys of the main tables as a foreign key. That's what you mean by. A foreign key is a key used to link two tables together. Right? A foreign key is used to link two tables together. A foreign key is a field or collection of fields in one table that refers to the primary key in another table. That's what you are going to actually do here. Probably what he is doing is person ID, last name, first name, age. This is one table, person's table. This is the orders table. Right? Somebody is buying, right, from Amazon or whatever. So orders table will contain order ID, order number, and who has given the order. Those names won't be there, but only the ID will be there here. So order ID, order number, and person ID. Now from this you can easily understand that this order number 1 is placed by person number 3, meaning that Peterson. So when you join these two, such that person ID of orders table should match with person ID of persons table, then only this record, this entire record is going to attach. That's what you mean by. So with this, the advantage is that when you link like this, that means you cannot have a data here in this table. You can't have a value here that is not available within this. That is the advantage of foreign key, primary key relationship. So this column can contain a value that is existing only in this table. Nothing else is possible when you actually link with foreign key constraint. That is the advantage that you are actually going to get that. But how are you going to create tables of that particular nature? You can see here. Create table orders. Orders table, if you see here just now, so it has got order ID of its own, order number of its own, but person ID of other table. Person ID of other table. So how are you going to create like that? Here you can see. Create table orders, bracket begin, order ID, integer, not null. Order number, integer, not null. Person ID, integer. But this is not independent. It is linked to the other table. So you say here primary key of order ID. Right? Order ID is a primary key. You are actually defining. But the foreign key of person ID. You see, this person ID, what you have here, is a data that is coming from the other table, whose ID is going to be something. Like you say then foreign key of person ID. And then you have to talk about what is the table. So that's why you have to use the keyword like references. References what? So you have to specify the table name and the column name within that. That means person ID of this table is nothing but person ID of persons table. Like this, when you link it, the advantage is that the orders table will never accept any data coming into this whose person ID is not existing in persons table. That is the advantage. Like the database constraints will not naturally be applied. You can't add some other name which is not existing in the persons table. So that is the advantage of primary key, foreign key relationships. So you can see all these things here. And create table orders, all that is totally different. MySQL syntax only you try to learn. So with constraint name and all that, you can always do this. Constraint, FK underscore person order. Any constraint name you can give. Foreign key, normal, most of the time, foreign key constraints begin with FK underscore. But you can give any other name also. Just to understand, they follow certain naming convention. Constraint name, foreign key of person ID. References, persons of person ID. And then how are you going to alter the table and all that? You can easily do that. Alter table orders, add foreign key of person ID, references, persons of this. Right? Those are simple things actually. But only if you just simply read and then come out, you may get a feeling as if you have understood. But better you actually use your MySQL client, execute all the commands, then slowly it becomes a part of you. Don't by heart. First general idea and then you practice. So very much it is required there as a part of it. Similarly, check constraint. So check for certain value, all that is possible in fact. You can see here, MySQL, create table persons, ID integer not null, last name something, first name something, age something. And then what is he saying? Check off a condition. Check if age is greater than or equal to 18. Then because of this, what happens is, let us say you are maintaining voter IDs of all the persons. And you already know that voter ID can be given to a person only when the age is greater than or equal to 18. So in case like you are actually trying to insert a record whose age is less than that, by mistake you are trying to insert, the system will not allow. Straight away it will tell that no, this person's age is less than 18, not permitted. So this is the advantage of designing your table with appropriate constraints so that no wrong data can enter into the table in whatever form, either through internet online form or using a command. By any of these means, it will not be accepted because the table itself is created so that database server will always enforce all these constraints. Any data that is trying to get into the system, which is violating the constraint, will not be added. Whether it is directly added using a command or coming through the internet by whatever means, ultimately it has to come to that database server only, right? So that server is already informed about how the structure of the table is, what are the constraints, all that. Once told, it will faithfully like apply all those constraints and will protect your database. That is the advantage of designing appropriate database with proper constraints. With proper constraints. So check off A is greater than or equal to 18. You can apply that to any of these things. If a name should contain a minimum of this many characters, all those things you can actually use. Similarly, default value. In case the user doesn't supply, what should be the default value? Many a time default value is null value. Or for certain integer kind of things, it's going to be 0 kind of thing. If you want to have a different value, then you can always mention. For example, sometimes date value. Date default value may be the current date, the date of creation of the record. That kind of things you can always mention, in fact. So you can see here what he is talking about. This may be only as an example he is giving, but may not be many times it's not correct. So what is he saying? All this city, varchar of 255 default followed by this. So the default city is CNIS kind of thing. Maybe it's okay when like Telangana government is maintaining records of all the information because many people residing in Hyderabad, so the default city can be Hyderabad kind of thing. Something like that. If you don't use specific value, it is default as Hyderabad. If you give any specific value, that specific value will be stored. Similarly, getting a date and all that, you can see here, order date, default is going to be get date. But this is not actually MySQL specific. MySQL specific is somewhat different. You can see this is how it is. Alter table persons, alter city, set default, CNIS. So MySQL only, part only, you will have to learn. How to drop is always as usual. no issue. There is another important constraint called auto increment. This is very useful, especially for ID numbers, which are likely to be always in the increasing order of numbers. Student IDs, let us say you want to give starting from 101, next ID must be 102, next ID must be 103, and so on. So we don't have to remember what is the last ID that I gave, and okay, let me give all that. So the system can be informed that ID, I am not going to supply any ID, but you calculate the ID and then simply insert the records with the other columns what I am going to supply. That's what you really mean by it. You can see here how to do that. Create table persons, person ID, integer, not null, auto increment. See, this auto increment will ensure that the next record will be one more than the last record that is already inserted. That is the advantage of auto increment feature. Other things you can easily understand what is going on. Keyword to perform an increment feature, whatever. See here, insert into persons of first name, last name, values of this. Whereas ID is not given. So the ID is going to calculate on its own and then do all that. So whereas here, then what should be the starting value and all that? Somewhere you have to mention, definitely. Alter table, persons, auto increment equal to 100, like that. Then it's going to be starting from 100 onwards. So like that. See, if you learn the system properly, you can use it very to the efficient fashion, so that you don't have to do anything on your own. So always it's going to take care of it. Sequence and all that is different. Oracle only has sequence numbering, minimum values and all that. That is different. So dates, you have like what kind of functions are there on that, you can easily see. MySQL comes with the following data types for storing. One is the date, that takes care of only date in this particular format. So first 4 digits are going to be representing year, hyphen 2 digits month, hyphen 2 digits date. For that, the corresponding data type is date actually. Date time, there is another data type, but for that you can actually add the data in this particular file. But all this in the form of string actually. Within the code, in this format, you can actually store the information. Date time includes date as well as time. Timestamp includes, like again, the same thing as you can see. So DD, minutes, date time or timestamp, both are one and the same. Year means only year will be there, either in 4-digit year or a 2-digit year. So depending upon the server on which you are working, you must understand the corresponding or use the corresponding data types. Remember that. See, this is the data that is existing. Queries can be like this. Select star from orders where order date equal to, within quotes, all this. Even though it is order date, but you have to specify in this particular file. So what are the various data types that are supported in MySQL? You can see here, MySQL data types in version 8. You have character, where you can specify the size, varchar size, this is fixed length string, this is a variable length. Binary of size, raw data kind of thing also you can, variable binary and all that. Tiny blobs, blob means binary large object. Whenever you want to store like information, like for example, an image data you want to store, an image as a field you want to store. Image is a raw data, and a lot of bits will be there. So that entire thing you can store in the form of blobs. We call them binary large objects. So this is going to be small in size. 255 bytes is the maximum this thing. Tiny text. Here it is raw data, whereas here it's going to be text. Simple text. Then the maximum that you can store is this many number of bytes, 64K or 65,535 bytes. Blob size, medium text, like that. Very large data also you can always do that. Right? So just go through these things, practice, and be familiar with. We will have another class tomorrow. But you will appreciate all this only when you go through and then ask relevant questions. So you can spend time on your doubts. Okay, so today we will stop at this session. If you have any specific questions, yeah. Some are waiting to join. I don't know. Like, okay. So, all right. So, any questions then? It's okay. Shall we close the session? Are you all there? Not there? Sleeping in the afternoon?
Yeah, yes, sir. Yeah.
Okay. Shall we close then? So practice.
Ah.
Try to practice.